Okay, I see we're live. So, yeah, today I would like to continue with chapter 11, writing automated test, and last time we read section 1, how to write test, and today it's look like it's not big section, so maybe we finish chapter 11 and continue with controlling how to test or run. So yeah, I think we are ready, so let's jump straight into it. So controlling how tests are run. Just as cargo run compiles your code and test run the result in binary, cargo test compiles your code in test mode and runs the result in test binary. The default behavior of the binary produced by cargo test is to run all the tests in parallel and capture output generated during the test run, preventing the output from being displayed and making it easier to read the output related to the test result. You can, however, specify command line options change this default behavior. So all our tests run in parallel. So this is nice. So it should, yeah, you know, it's annoying when you write more and more tests. At some point on your continuous integration or whatever time you need to run it, it start being annoying when it takes some time. So when they run in parallel, it's save the time, and this is something good. So some command line options go to cargo test and some to go to the resulting test binary. To separate those two types of arguments, you list the arguments that go to cargo test followed by the separator and dash dash, and then the one that go to the test binary. Okay, let me check this again to separate the okay, so we have two types of arguments, one going to the test command itself and another is to binary. So if we want go to binary, we need to do dash dash as separator and then our arguments for the test binary. Okay, I see. Running cargo test help displays the option you can use with cargo test, and running cargo test dash 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 help display the option you can use after the separator. Okay, let's actually we had some code from previous time, and let's just try to run and see. So cargo test dash dash help, and okay, we can see so this is basically the arguments for the test command. And let's quickly try cargo. Oh, it's even have a tip, run cargo test dash 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 help. And provide some information. Yeah, it's actually a lot of stuff here. Include ignore run, ignore, and not ignore test, ignore bench, runtime time, shuffle, some docs. Okay, actually a lot of stuff. Maybe let's continue the read. So running test in parallel or consecutively. Consecutively. Okay. Yeah, makes sense. Sometimes we need to run it one by one, not in parallel. So when you run multiple tests, by default they run in parallel using threads, meaning they finish running faster and you get feedback quicker. Because the tests are running at the same time, you must make sure your tests don't depend on each other or on any shared state, including a shared environment such as current working directory or environment variables. For example, say each of your tests runs some code that creates a file on disk named text_output.txt and writes some data to that file. Then each test reads the data in that file and asserts that the file contains a particular value, which is different in each test. Because the tests run at the same time, one test might override the file in the time being another test writing and reading the file. The second test will then fail, not because the code is incorrect, but because the tests have interfered with each other while running in parallel. One solution is to make sure each test writes to a different file, another solution is to run the test one at a time. If you don't want to run the test in parallel, or if you want more fine-grained control over the number of threads used, you can send test threads flag and the number of threads you want to use to the test binary. Take a look at the following example. So yeah, we set the number of test thread 1, telling the program not to use any parallelism. Running the tests using one thread will take longer than run them in parallel, but the test won't interfere with each other if they share state. Yeah, of course, let's write this one. Cargo test. And test threads. Yeah, something like this. Okay, it's super fast. Yeah, our tests are really simple. And it works fail. Let's quickly fix it. Okay, I think it runs super fast after we run, so it's not rebuilding anything. And after a change it was slightly longer. Like, let me do it again. You see there was 0, 0, 0 and now it 0, 1 seconds. So definitely affects performance. And let's do change again, and looks like with 2 threads it was faster, but yeah, not sure. Not important right now. Let's continue. Showing function output. By default, if a test passes, Rust test library capture anything printed to the standard output. For example, if we can call println macro in a test and the test passes, we won't see the println output in the terminal. So we'll see only the line that indicates the test passed. If the test failed, we see whatever was printed to the standard output with the rest of the failure message. As an example, listing 1110 has a silly function that prints the value of its parameter and returns 10 as well as test that passed and the test that fails. Yeah, let's create new project. So cargo new testing 11.2. Let's copy this code snippet. So what we have here, we have a function. It do a print. I got the value. Prints the value we pass to the function and return 10. So we can do let x so yeah, it prints. I got the value 22 inside the function and return at x is equal 10. Okay, and now we have tests. This test will pass, so we do actually the same what we did in main function. We call the function and compare it with the 10. This test will fail. Okay. I think we had something to expect fail in the previous section. But yeah, let's quickly run this one. So yeah, left 5, right 10. Okay. Everything clear here. So when we run those tests with cargo test, we'll see the value output. Yeah. Note that nowhere in this output do we see I got the value 4, which is what is printed when the test that passes runs. And that output has been captured. The output from the test that failed, I got the value 8, appears in the section of the test summary output, which also shows the cause of the test failure. If we want to see printed values for passing test as well, we can tell Rust to allow to also show the output of successful test with show output. Yeah, I want to quickly check. Uh, okay, we can use this instead, or okay, should panic maybe, or should panic. Yeah, I read the section like a week ago and already don't remember in details. But still remember it was somewhere, so yeah. And we can try it. So if we do like this, and then cargo test and show output, and you see we have this I got the value 4 and I got the value 8 and the panic message. Actually, let's test without this show output as well. In this case, you don't see this additional output like yeah, like this. You don't have this information. In case we don't have this parameter show output, we just see the tests are passed. Okay. Let's move forward. So when you run the test listing 1110 again with the show output flag, we see the following output. Okay. Running is subset of test by name. Sometimes running a full test suite can take a long time. If you are working on a code in a particular area, you might want to run only the tests pertaining to that code. You can choose which test to run by passing cargo test, the name or names of the tests you want to run as an argument. To demonstrate how to run a subset of tests, we'll first create three tests for our add2 function as shown in listing 1111 and choose which one to run. So yeah, let's comment out everything used before and paste this code. Oh, and also yeah, comment out this part. So we have simple function which add 2 to the argument and return the result, and have 3 tests here. So let's take a look how we can run particular one. So yeah, if we run everything, if we run the test without passing any arguments, as we saw earlier, all the tests will run in parallel. So let's confirm this. Cargo test. Everything run in parallel. Yep. So running single test, we can pass the name of any test function to cargo test to run only that test. 100. Okay, so it will be simply function name, cargo test 100, and you see only one was ranked, and we maybe can pass another one at 2 and 2. Unexpected argument. Did I misspell it, or I cannot pass it like this? So if if I send just this one, it works. So let's take a look. So only the test with the name 100 ran. The other 2 tests didn't match the name. The test output let us know we had more test results that didn't run by display to filter out at the end. I can specify the name of multiple tests. Yeah, we just tested in this way. Only the first value given to cargo test will be used. But there is a way to run multiple tests. So filtering to run multiple tests. We can specify part of the test name, and any test whose name matches that value will be run. For example, because 2 of our test name contains add, we can run those 2 by running cargo test add. Okay, cargo test add. Let's try this one. Cargo test add. And yeah, you see 2 tests were ran. This command ran auto test with add in the name and filtered out the test name 100. Also note that the module in which a test appear becomes part of the test name, so we can run all the tests in the module by filtering on the module name. Module name is the tests. Let's change it to, I don't know, my tests, so it will be more clearer. And cargo test my, let's just do this one. Okay. And if we just copy paste the test but name another test, so if we run cargo test, we have running 6 tests, and if we try again with my tests, you see duplicated tree from another module filtered out by module name. Yeah, that's cool. Okay. So ignoring some tests unless specifically requested. Sometimes if use specific test can be very time consuming to execute, so you might want to execute them during most runs of cargo. You want to exclude them during most runs of cargo test rather than listen as arguments all tests you do want to run. You can instead annotate the time consuming test using the ignore attribute to exclude them as shown here. So we can add ignore. After test, we add ignore line to test we want to exclude. Now when we run our test, it works, run, but expensive test doesn't. So cargo test, and you see one is ignored. This is good. The expensive test function is listed as ignored. If we want to run only the ignored test, we can use cargo test ignored. Okay. Cargo test ignored. And you see only one ignored test was run. Okay. So by controlling which test to run, you can make sure your cargo test results will be fast. When you are at a point where it makes sense to check the result of the ignored test and you have time to wait for the results, you can run cargo test ignored instead. If you want to run all tests whether they ignored or not, you can run cargo test include ignore. Okay. And for sure, let's try this one. Cargo test include ignored. And you see all 6 tests were ran. Alright. This is it for section 2. Let's move on to section 3. Okay. Test organization. As mentioned in the start of the chapter, testing is a complex discipline and different people use different terminology and organization. The Rust community thinks about tests in terms of 2 main categories: unit tests and integration tests. Unit tests are small and more focused. Testing one module is isolated at a time and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way any other external code would, using only the public interface and potentially exercising multiple modules per test. Writing both kinds of tests is important to ensure that the pieces of your library are doing what you expect them to separately and together. Yeah, makes sense. So, unit tests. The purpose of unit test is to test each unit of code in isolation from the rest of code to quickly pinpoint where code is and isn't working as expected. You put unit test in the src directory in each file with the code that they're testing. The convention is to create a module named tests in each file to contain the test functions and to annotate the model with cfg test and the test module in cfg tests. Yeah, this is what we had here. Initially it was module tests, but if you, it's interesting, if you always name it test, there is no way to filter it out by module name because all the module names are the same. Not sure, let's see. The CFG test annotation on the test module tells Rust to compile and run the test code only when you run cargo test, not when you run cargo build. This saves compile time when you only want to build the library and save space in the resulting compile artifact because the tests are not included. You'll see that because integration tests go in a different directory and they don't need their CFG test annotation. However, because unit tests go in the same files as the code, you'll see -cfg tests to specify that they shouldn't be included in the compile result. So integration test don't need this annotation. However, because unit tests go in the same directory, you use, okay, yeah, I got it here. So we specify it because we don't want to compile it to the binary, and yeah, we don't basically, yeah, don't want to include our test code in our binary. Doesn't make any sense. But if we remove this one, it still will work. Like test will be running, but in this case, I guess I tested because before, because I don't know what this CFG doing. So if we do cargo test, you still see the all test running, but in this case it will be added, this module code will be added to the binary, I guess, from what we just read. So this code is automatically generated test module. The attribute CFG stands for configuration and tells Rust that following item should only be included given a certain configuration option. In this case, the configuration option is test, which is provided by Rust for compiling and running tests. By using the CFG attribute, cargo compiles our test code only if we actively run the test with cargo test. This includes any helper function that might be within this module, in addition to the functions annotated with test. Sorry, yeah, I lost my thought, and let me quickly read it again. So automatically generate test module. The attribute CFG stand for configuration and tells Rust that the following engine should only be included given a certain configuration option. In this case, the configuration option is test. Okay, so this is configuration shorthand, and we say configuration option is test, which is provided by Rust for compiling and running tests. By using CFG attribute, Cargo compiles our test code only if we actively run the test with cargo test. This includes any helper functions. This includes any helper function that might be within this module in addition to the function annotated with test. So basically, if we have some functions inside this module but not marked as tests, it still be included like helper one. Okay. So testing private functions. There is debate within the testing community about whether or not private functions should be tested directly, and other languages make it difficult or impossible to test private functions. Regardless of which testing ideology you adhere, Rust privacy rules do allow you to test private functions. Consider the code in listing 11.12 with the private function internal header. Okay, this was pub, but let's comment out our previous code, and internal header is private function, it's not marked as pub. And we can straight test it, right? Yep, it works exactly as we expected. So note that internal header function is not marked as pub. Test adjust Rust code. And the test module is just another module, as we discussed in the past for referring to an item in the module 3 section. Items in child module can use the items in their center modules. In this test, we bring all of the test module partner items into scope with use super, and then the test call internal header. If you don't think private functions should be tested, there is nothing in Rust that will compel you to do so. Yeah, so the Rust is at this ability, and if you like strategy or ideology, whatever you think you shouldn't do it, you just cannot do it. Basically, yeah. If you don't want, you shouldn't. So, but if you think it's you like idea to test, I personally don't have any opinion on that. I think it depends on situation. If you see good reason to write a test, just write it. If it helps you to write a code, or if it helps you to prevent bugs, why don't do it? But I believe, yeah, there could be some arguments why you shouldn't do it, and some um, software architecture concepts, etc. But anyway, it's not interesting to us right now. Integration tests. In Rust, integration tests are entirely external to your library. They use your library in the same way any other code would, which means they can only call functions that are part of your library public API. Their purpose is to test whether many parts of your library work together correctly. Units of code that work correctly on their own could have problems when integrated, so test coverage of the integrated code is important as well. To create integration tests, you first need a tests directory. So the test directory, we create a test directory at the top level of our project directory next to src. Cargo knows to look for integration test file in this directory. We can then make as many test files as we want, and Cargo will compile each of the file as individual crate. So, and Cargo will compile each. We can then make as many test file as we want, and okay, each file in the test directory will be as individual crate. All right, let's create an integration test within the code and listen 1112. Still in the src librc file, make a test directory and create new file name tests integration tests rc. Your directory structure should look like this. So header, okay, we have header project as I remember. So we need folder tests and integration test rc. All right, and we can add following code snippet. Each file in the test directory is a separate crate, so we need to bring our library into each test crate scope. For that reason, we add use header at the top of the code, which we didn't need in the unit tests. We don't need to annotate any code in test integration test with config test. Cargo treats the test directory specially and compiles file in this directory only when we run cargo test. Run cargo test now. Yep, cargo test. And yeah, here's our integration test, I guess. We have also it adds 2 as a unit test, but we see it's related to the test mode, which is name of the module. So yeah, we can find it here, I guess. You see, this is test mode. And let's even rename our test. To make sure we see it. And yeah, you see there is adds to integration. So the three sections of output include the unit test, the integration test, and the doc test. Note that if any test in section fail, the following section will not be run. Okay. Oh, there is also docs tests section. Okay. Note that did we already read anything about the docs? I don't think so. But maybe I just forgot. Was it in docs? This feature helps keep your docs and your code in sync. We'll discuss how to write documentation test in the it will be in chapter 14. Yeah, very good. Note that if something failed, next section will not be run. So if unit test fail, it will not run integration or docs test. For example, if unit test fail, there won't be any output of integration doc test because those tests will only be run if all unit tests are passing. Yeah, exactly. The first section of unit test is the same as we've been seeing, one line for each unit test. One name internal that we added in listing 1112, and then summary line for the unit test. The integration test section starts with the line running. Do we actually see it? I haven't paid attention. Oh yeah, it's actually running test integration test RC. And if they're same for unit test. Compiling. Running 7 test. Not says what exactly it runs, it just, yeah. Okay. But here it specifically says running test integration test RC. And then docs test header running 0 tests. Yeah, this is fine. Next, there is a line for each test function in that integration test and summary line for the result of the integration test just before the doc test header section starts. Each integration test file has its own section, so if we add more files in the tests directory, there will be more integration test section. We can still run a particular integration test function by specifying the test function name as an argument to cargo test to run all the tests in the particular integration test file. Use the test argument of cargo test followed by the name of the file. Yeah, let's try this one. So we do cargo test, then dash dash test, and then name of the file integration tests, right? Yeah, and it works. There is a compiling, and then one test is ran. Okay. This command runs only the test in the test integration test file. Okay. Now submodules in integration test. As you add more integration tests, you might want to make more files in the test directory to help organize them. Okay. For example, you can group the test functions by the functionality they're testing. As mentioned earlier, each file in the test directory is compiled as its own separate crate, which is useful for creating separate scopes to more closely imitate the way end user will using your crate. However, these min files in the test directory don't share the same behavior as files in the src do, as you learn in chapter 7 regarding how to separate code into modules and files. This different behavior of test directory files is most noticeable when you have a set of helper functions to use in multiple integration test files and you try to follow the steps in the separating module into different files section of chapter 7 to extract them into a common module. For example, if we create test common rc and place a function named setup in it, we can add some code to setup and that we want to call from multiple test function in multiple test files. Okay, yeah, makes sense. Want to have some common functionality which we would like to use in many tests, maybe in different files. Okay. When we run the test again, we'll see a new section in the test output of common rs file, even so this file doesn't contain any test functionality, nor did we call the setup function from anywhere. So yeah, we create a file in common rc, so it's mean it has separate crate for integration test, as we read earlier. Having common appear in the test results with running 0 test displayed for it is not what we wanted. We just want to share some code in with the other integration test files. To avoid having common appear in the test output, instead of creating test common rc, we'll create test common mod rc. The project directory now look like this. Okay, let's just do it. Common mod rc and some setup function. This is older naming convention that Rust also understands that we mentioned in the alternate file paths section of chapter 7. Naming the file this way tells Rust not to treat the common module as an integration test file. When we move the setup function code into command mod rc and delete the test command rc file, the section in the test output will no longer appear. File in the subdirectories of test directory don't get compiled as separate crates or have a section in the test output. After we create in test command mod rc, we can use it from any of the integration test files as module. Here's an example of calling the setup function from it adds to test in test integration test rc. And let's try do this. So use common and we can do common setup, then unresolved import command. Think we missed something. I think we need to name it or not. Oh, it's not use, it's mod instead, yeah. So we do it mod. It's private, then we should make it public. And everything looks fine. Yeah. Okay. So note that the mod command declaration is the same as the module declaration we demonstrate in listing 721. Then in the test function we can call the common setup function. Yeah, just we did it. Integration test for binary crates. So if our project is binary crate that only contains a src main file and doesn't have a src librc file, we can create integration test in the test directory and bring one function defined in the src main rc file into scope with a use statement. Only library crates expose function that other crates can use. Binary crates are meant to be run on their own. So only if we have library like src librc, then we can have integration test. Okay, even if we have it, we can create test that we have in the main rc because it's not part of the library. Only library crates expose functions that other crates can use. Binary crates are meant to be run on their own. Okay. Yeah, make sense, I think. This is one of the reasons Rust project that provides a binary have a straightforward src main rc file that call logic that lives in the src a libRC file. Using that structure, integration test can test the library create with use to take the important functionality available. If the important functionality works, the small amount of code in the src-min-rc file will work as well. And that small amount of code doesn't need to be tested. Okay. Yeah, I think this is all makes sense. So, and there is a summary for chapter 11. Rust testing feature provide a way to specify how code should function to ensure it continues to work as you expected, even as you make changes. In test exercise, different part of a library separately and can test provide implementation details. Integration test check that many parts of the library work together correctly, and they use the library public API to test the code in the same way external code is used. Even so, Rust test system and ownership rules help prevent some kind of bugs. Tests are still important to reduce logic bugs having to do with how your code is expected to behave. Let's combine the knowledge you learned in this chapter and previous chapters to work on the project. So, yeah. This is exciting part because we are moving to chapter 12, not today, but yeah, next will be chapter 12, and this is about building command line program. So it's like more fun to build something than just reading about separate language constructs. But back to the chapter about testing, if I will compare to the like JavaScript, TypeScript world, like right now I'm working on React Native, React.js projects, and this is kind of painful to start testing something. You need to set up so many things, like you need to bring, sometimes you need to JS, some testing libraries, and etc to be able even start test like simple helper functions, simple unit test to it. And this is like in Rust, you have built-in mechanism. You don't even need to leave your code. You can just add your test near to your code. That's super cool. It motivates you to use test because, as I said in this, I don't know, for example, React.js world, it's really demotivating part to okay, I want to write test. I joined some project and I want to write test, or I create new project, and you need a ton of setup to do. Yeah, if you did it like 100 times, it maybe not a big deal, but for newcomers, it's really painful. Start testing, it's kind of a challenge. In the Rust, as I see so far, it should be super easy and like a common practice, like everyone use test, just because language give you this ability, like language or language tools, I don't know, whatever. So yeah, this is next chapter. Oh, it's big one. 6 sections, and yeah, it should be super fun. We will build some command line tool, and we somewhere past the equator of the book. Right now I'm thinking to start building some full stack app, maybe with Rust backend and Rust frontend, just to have fun and yeah, practice the Rust. But I think we need to cover at least some of the next chapters first. Yeah, there is a lot of, there is concurrency, there is some pointer stuff, cargo and crates, workspaces. Yeah, workspaces is interesting part for the full stack app for sure. So yeah, the goal to finish the book as soon as possible, and start messing around with the projects. So let's take a look what we have in the Rustlings before they finish the stream. So Rustlings. So there is quiz 2. And what description says us? Oh, this week I learned cool new feature. A new feature for me of Tmax. You can zoom the pane, so it's super nice. You can zoom and zoom out, and this is super helpful. Let me I don't know if I need to tweak a layout a bit, but maybe I will put myself somewhere on the top. Should be fine. And yeah, so this is a quiz for following sections: strings, vector, move, semantic, model, enums. Let's build little machine in the form of function. As input, we are going to give a list of strings and commands. Those commands determine what action is going to be applied to the string. It can either be uppercase the string, trim the string, append bar to the string a specified amount of times. Okay. The exact form of this will be: the input is going to be a vector of a two-length tuple. The first element is the string, the second one is the command. Okay. The output element is going to be a vector of strings. No hints this time. Okay, let's see. We have my module transformer. It's supposed to be a tuple. How I should write the tuple type? Is it string and command? So it might be no, it should be vector of string and so my module transformer cannot find command in this scope. Line 33. So go to the line 33, command unresolved, import my module. Line 46. So maybe is a super my module like this? No? Okay, now we have some different output. So start somewhere here. For string command in method not found in string command. Let's back to description. The input is going to be a vector of two length tuples, so it should be a vector. Okay, so we resolved the syntax error. Now our test isn't working. So test it works, failed. Here we have a transformer of vector hello into. Okay, this is string, this is command uppercase. So the command is basically a num, okay. And we can use match so here's we need uppercase command, here we need trim, and append, doing append n times bar to the string. So looks like super clear what we need to do here. So command match. Let's quickly take a look at the book, because I already forget how to use match. Okay, this is enums match control flow. So you see the value of the reading the book. You don't need to memorize everything. You just should know about the concepts. Like we know we have enum concept, and then we can use match on the enum, and it will look like this. Okay. So command uppercase and then I don't know if we have what we need to do. We need to do edit to output. So our output push the string any LSP rust string uppercase okay to uppercase. Expect expression in a let statement. What I did wrong here? Why I don't have LSP quiz 2? No, it's super annoying. I don't understand why it's not show me any types, any function. The go to definition isn't working as well. Okay, let's write command append and string from bar Okay, first of all, I wrote this one. Not correct. And this is also expected integer font U size. And it suggests to do dereference. Okay, this is last test isn't passed because we just push bar, but we so let mat result string output push result give me 1 sec. Okay, I'm back. So what we need here, we need result is equal something like this format. I don't know what this means. So was it correct? Okay, this is This is definitely not correct. And let's find the what we do with strings. Like we can push str. Oh, this is interesting. Can we just do string push str bar? Yeah, like this. And then mismatch types. Cannot borrow string is mutable as it is behind the reference. String is string. Remove this mat. And we did it. Yeah, definitely feels like without practice, it's super unclear how to use it. So starting writing program in the next chapter will be, I think, super helpful. So the next exercise is the options. But I will jump on it next time. And yeah, that's it for today. Thank you everyone for watching. We'll see you next time.